Do you see my screen? Anyone? Yeah, that's nice. So today I would like to present you our new recent work, which has been has appeared at Kalin 2020. It's called SumTitles, Summarization Dataset with Low Extractiveness. I'll explain in details what's going on here and why do we actually want to do this. Seconds. So first of all, about the team. This is our joint work with Konstantin Chernis, our junior researcher, and Ekaterina Artemova and Irina Pyankovskaya, our team leader. So first of all, I'd like to start with some motivation of our research, why we actually want to have such a resource, why the task is interesting. Actually, there are a lot of textual discussions in the social media. I think everybody knows this nowadays. So there are like Telegram chats, Facebook comments, Twitter, and so on. A lot of discussions going on right now in the internet. So I think everybody of you have been seeing such things like in your everyday life. And it would be great to spend less time to read them. So there are a lot of comments, but not all of them are useful. The social networks, they're trying to solve this in a way. They're trying to do the ranking of the comments and like pushing up the most useful comments, but still one comment is not all the discussion. The whole idea of the discussion contained inside the discussion in maybe almost all the comments themselves. So it would be nice to have some method to actually summarize the discussion, and this is that was our motivation. Of course, we were not the first who have thought about such thing as dialog summarization. The first attempt, to my knowledge, is the AMI Corpus. It has been released in 2005, so it's 15 years ago. But it contains only 142 meeting recordings. It is a really nice corpus containing the summaries, containing even the video of the meetings themselves. A lot of information actually, but this is only 100 of dialogues. It's not really working nowadays. In like 13 years, Gu and Chen have been released dial sum, which is a reshape of AMI, initial AMI corpus. They have been like recollected or maybe chopped to slices some of the meetings, and they collected about 8,000 dialogues of shorter size, shorter length, and they used the themes of these dialogues as the summaries of the dialogues. It's maybe not the best approach, but it is still one of the best available of them at the moment. At last, in 2019, our colleagues from Polish Samsung office, they have released so-called Samsung corpus, which has been collected by the crowd workers, which they have the task to make a conversation on some specific topic, which has been described for them initially. And this raises some questions to this setup, and you will see that there are some maybe little issues with this setup. So the dataset statistics, this is like AMI. There are average of 4 speakers, 800 utterances in each dialogue. It's pretty long. And in the summary, there are about 9 sentences at average. In the dial sum, unfortunately, they have lost the speakers, number of speakers information. There are 10 utterances at one dialogue, and they have 1 sentence exactly of the summary. It's actually not exactly a sentence, it's a number of tokens, I would say. And Samsung, they have somewhat big corpora, about 16,000 of dialogues with 2 speakers at average and 9 average text utterances per dialogue. This is pretty close in some sense to the AMI corpus, but in other sense it's not. So we decided to collect our own corpus just because we can. And we decided that we could do better because there is an available source of the data which we could collect, and this is subtitles. This is movie subtitles and of course series subtitles, and we decided to collect these and pair them with the synapses and plots. I'll explain in a few minutes what is this. And this turns out to be working, and it is also bringing some new questions, which I'll be discussing with you in a few minutes. So first of all, we need to understand a few core concepts here. These subtitles themselves are the captions for movies and series episodes. These subtitles typically does not contain the participants' names, some specific scene separation, something like this. So this is only the visible to human text. So this is the text accompanying some picture, and the subtitles are plenty. I think everybody knows the corpus Open Subtitles. It is a multilingual corpus for many movies and series episodes. Next thing is a script. Scripts are much more scarce than the subtitles. There are about 1,000 scripts available. But scripts are definitely better than subtitles because they contain the participant names, they contain scene separation, and we could use it to actually get the specific dialogues from the scripts. As seen, it is some subdivision of the movie or an episode of a series, which is complete. So it has its beginning, it has its ending. Its meaning is complete. It's like the discussion which is over. The next thing which is need to be understood, this is plot summary. Plot summary is a few sentences text which is describing a movie or a series episode contents. This is not much, but it's still available. It's pretty nice to have. A synopsis, it is much more, much larger text, which is pretty useful when we have scripts. So the idea is here that we could split the synapses into some into the pieces which are describing the scenes. Maybe not one scene at once, but at least several scenes in one sentence, which is really nice because these we could use for the summarization process. And also we need some concept of cast, which is a full list of character names and sometimes alter egos. So like if we take the Avengers movie, it is Tony Stark, and the same person is Iron Man also. So this is the sample of a plot. This is of my favorite movie of Blade Runner, and it is describing really nicely Los Angeles of 2019, which have passed successfully. But the interesting thing that here in one paragraph, the whole movie is described. But the subtitles, they're much more. They contain much more information. Here is the opening scene of the movie Blade Runner. So this is only one scene, and it even has no one. It has no one sentence description. But if we have a script, like this is a movie Dallas Buyers Club, then we have and we have synapses. Then we could pair the synapses with a sentence. So Ron goes to a hospital and Eve tries to help him, and we have the short scenes, short dialogue, which is actually described by this sentence, and we could use this to train the summarization. So I was saying about the scenes, about the pairing, and what I want to discuss with you, it is the splitting itself, because when we have a script, we could easily split it into the scenes because we know how to split it. It's there are the particular scene separators in the script, but when we're splitting the synapses into the sentences, then the sentences need to be attached to a scene, attached to a specific scene, maybe to several specific scenes. We do not know exactly for that. And this is the algorithm we have been used for this. There are alpha, beta, gamma, delta hyperparameters which we need to tune. And we have seen the scene list, the scene sense, the sentences of a synapses, and what we have, we need to calculate cast similarity for the scenes and scene sense. So we calculate the similarity between each scene and each sentence if the sentence is actually mentioning some of the characters. And then we have some matching. So it's not the perfect matching, but still we could use it. And then again, we could use text similarity for scenes at synapses sense. It's also not perfect, but it is really useful. So we have similarity for each scene with each sentence by means of two parts, cast and text. And then we have the similarity metrics, which have been computed as the weighted sum of the output of these two types of the similarity measuring. Next, we take the restricted data Tamworth algorithm. if you're not aware of the data time of the dynamic time warp algorithm, it is taking the one time series and another time series and trying to like bend one on another so we could match them. So we have the restricted version of this algorithm, which says that each scene could have almost only one sentence for the match. So each scene has one sentence, but sentence could have multiple scenes. This is our restriction to actually lighten the computation in this case, because in typical movie there are about 100 scenes and somewhat about 100 sentences in synapses. So you can compute that this is about 10,000 comparisons at least. So again, after we have the scene to scene metrics, then we use specific annotation processing, which is just get what I've told you before. This is the idea of each scene will be attached with a sentence. Maybe some scenes will be merged together. Then we just sorting, merging, and trying to find a best split of the scenes. And this is the algorithm which is has been producing us really nice results, because previously I have shown to you the synapses to scene matching from the Dallas Buyers Club movie, and that was achieved automatically. So using this, we have been constructed three parts of our dataset SumTitles. The first part is called SumTitles. We use these subtitles because there are plenty, as I said. Unfortunately, we have no speakers there, but we have about 132,000 scenes in this, and average utterances in the dialogue is about the same as in AMI corpus. The average summary sentences is about maybe some other corpus like CNN Daily Mail. CNN Daily Mail, I think, is the most standard corpus for text summarization, so we could think of it as some kind of a reference here. The next thing is scripts. When we're splitting scripts and getting the alignment from the scripts, there are 21,000 of scenes available from there, and this is mostly publicly available scripts and partially the plots for the famous series Friends. Maybe you have seen it back in the day. The nice thing of the scripts part is that there are almost five average speakers in the scripts part, with 28 utterances and 4 sentences at the summary. Gold part is the subpart of scripts, which has been manually improved, manually checked. So it is small, but we hope that we could make it bigger during the next time period, there is almost the same number of speakers, almost the same number of utterances, and number of sentences. So we could compare the datasets, and we decided to compare the datasets by several means. One of it is so-called extraction scores. Extraction score of Siebels and co-authors in 2018, which takes the longest subsequence and makes this specific computation over it. The next thing is extractive oracle, when we know the true summary and trying to get extractively the sentences from a dialogue. And the last part is when we just compare the summary with an input. So we have a look at these three measures, and we understand that we could combine them, and we could produce some better measure, which we called extractiveness coefficient, because we could decide how extractive is the dataset itself, how extractive each summary for the datasets, for the dialogues. And again, we get the additional score of BERT score. BERT score is using the classic IDF with specific comparison of BERT embeddings. So the final results for the comparison is like that. As you can see, the SumTitles are really close to AMI and Samsung by the BERT score, and also we could see that scripts and Goldpart is much less extractive. So the AMI is somewhat extractive and really close to subtitles, but the scripts are really low extractive, while the Samsung is really hugely extractive, and this is an issue with this dataset. So this is what makes our dataset unique. We have the really low extractive, so that means abstractive dataset for the summarization, and we actually releasing the scripts to collect this dataset, so you could use the scripts and collect it by yourself. So also we have evaluated some baselines on this dataset, which is called the metrics for the baselines are classical root metrics, so 1, 2, and L, and we have evaluated BART and BERT's some Ext, which both based on some BERT models, and we could see that these results are not great, and they are much lower than the results for the CNN Daily Mail dataset. That means that the SumTitles dataset is a new challenge which need to be overtaken, and we still have a lot of research for the summarization in this, at least this year. I don't know, maybe in a few months there will be a model which will solve this like perfectly, but I don't believe in this. So the conclusion that we released a novel dataset, actually not the dataset itself, but the scripts to collect them, because we do not own the data. The data is provided by the in the open sources, so you could collect it using the interface. And we are releasing the splitting algorithm, which allows us and allows you to make this dataset. And we proposed a novel measure of extractiveness for the datasets, which I hope will be useful for the datasets, to compare the datasets on the summarization. So thank you, and I would have maybe a few questions if there are any.